Pressure pulse testing. Pressure pulse testing is performed to analyze the interval space using two and more wells. Pressure pulse testing consists in a series of rectangular pressure pulses of equal amplitude and duration created by alternating injections and shut-ins. Pressure variation caused by the pulses is measured in an observation well. Pressure pulse testing is implemented in several stages: survey design, field tests, interpretation, data analysis. Let's consider each stage in detail. Survey design. The key points here are determining optimum test periods and injection volumes, and determining the sensitivity to input parameters. Planning is performed in the following way. Input data, including core data, well logging data, past surveys, and production data, are used to determine the properties of the reservoir and near wellbore zone, such as permeability, porosity, and compressibility. Then, survey candidates are selected, a generator well and a receiver well. Now, pressure is modeled using simulation software. The modeled pressure is plotted, and the pressure amplitude at the receiver well is calculated. Then we determine how the survey period depends on input parameters. As a result, we accurately determine the minimum time required for the survey, operating modes for the generator well, and the well operation schedule. In this case, Model 3 was optimal, both technically and economically. Accurate measurements are made possible with the DMPT tool, sensitive to small changes in pressure and temperature. The tool contains a sapphire pressure sensor and a platinum temperature sensor, ensuring high accuracy measurements. The table shows the basic technical specifications of the tool. The tools are run into the reservoir top. Then, pressure recording starts. The generator well is shut in for a half period and starts to flow for the second half period at a constant rate. This procedure is repeated for the second period to create a perturbation at the receiver well. After the survey, the tools are retrieved. The third stage is the interpretation of resulting pressure data. These are raw pressure data for both wells. The first data processing step that largely affects the accuracy of determining reservoir flow properties is identifying and accounting for the non-periodic trend. The processing program offers several methods to identify the trend. The correct selection of the method minimizes error. The next steps are fast Fourier transform to identify unwanted noises outside the confidence interval, finding the first harmonic of pressure, calculating the pressure amplitude at the generator and receiver wells, and determining the phase shift. PPT survey has a practical value. We performed a number of tests and determined reservoir flow properties, transmissibility, permeability, and skin factor, permeability anisotropy. One of the objectives of anisotropy analysis is determining the direction in which permeability decreases, and barriers and fractures.